Hello there, welcome to CXC Math TV. Today we will be looking at bearings. So the important question of the day is, what is this bearings, right? Well, in mathematics, a bearing is just the angle in degrees measured in the clockwise direction from a north line. That's the first thing that we need to know about bearings. And the second thing is that we go in the clockwise direction. All right? So how the clock turns, that is how we read our angle. Now, bearings are usually given as three-figure readings. For example, 30 degrees clockwise from north is usually written as 030 degrees. Now, finally, problems involving bearings, we can work them out using sine rule or cosine rule. And this is where the trigonometry comes into play. Now, we use the cosine rule when you need to find a side and you know two sides and the included angle, or you need to find an angle and you know all three sides. Now, we use sine rule when you need to find a side and you know one side and three angles, or when you need to find an angle or a bearing and you know two sides and an angle. That's when we use sine rule. Now, bearings, just another way to look at bearings again. As we said, bearings are a way of expressing the angle between two objects. And there is a set rule in how we calculate bearings. As we said, these are the three things that we must remember. Bearings are always measured from the north line. Bearings are always expressed as three figures. And we always draw and measure bearings in a clockwise direction. Alright, that's just summarizing everything. Now, the next thing we need to look at is we need to know that there are three types of bearing questions. Alright, now there are three types of bearing questions, and information will either be given to you to construct a diagram to see how you attempt the question, or two, information is given to you with a partially filled diagram, meaning they might put in a couple of informations given, but they also leave out some of the information from off the diagram. And number three, information is given to you with a diagram and it is completely labeled, meaning they give you the information, but also they make sure all the information given is on the diagram for you to solve questions. So let's look at an example of each of these three different types. Now, the first question, it says a shipmate is planning the course for a voyage. The course is shown in the diagram below. He knows that he must sail from port A to port B on a bearing of 77 degrees, from there to port C on a bearing of 117 degrees for 1200 kilometers. In order to return to port A, the ship must sail on a bearing of 285 degrees. Calculate how far the ship will have to sail to return to its starting point. That is the distance AC. Now, in order to do this question, alright, we need to work out the distance AC. Cool, so we know that we're going to do some sort of calculation with sine or cosine rule. Now, first thing I want you to ask yourself is, which one of these types is this bearing question? Now, looking at it, we see that some of the information is on the graph. We see that they leave out the 117 degrees bearing from port B, so this is partially filled. So what we need to first do is put in that 117 degrees. Alright, so now that we put in that bearing, so we draw our north line from B and put in that 117 degrees. Cool. Now, look at this right here. If we were to call that angle right there that we input at port C X, if we call that angle X, given that we know that the angle at B is 117 degrees for the bearing, so if that angle down there is X, we know 117 plus X equal 180, because co-interior angles sum to 180. So if we transpose it, we'll get X is equal to 63 degrees. So now we can replace it with 63 degrees. Now pause. Now we will review all of these things later on when we cover geometry. All right, so if you are unfamiliar with some of these rules, we will cover them very soon in our videos next week on geometry. So stay tuned for that. Now, let's call the angle inside the triangle y. At point C, let's call that angle right there y. Now what we do know is angles at a point sum to 360. When you make one complete revolution from a point, that is 360 degrees. So we know 285 plus y plus 63 equal 360. And whenever we transpose that, we will end up get that y is 12 degrees. So now we can input that y is 12 degrees. Alright, now remember what we're trying to do. Remember we're trying to find the length AC. In order to find the length AC, we need to know some angles inside the triangle so we can solve the question. So that is the reason why we're finding these inner angles right here. So now, after we extend the north line at B, right, we're going to call the angle to the right of the north line of B Z. And we're going to call the angle to the left of the north line R. Now, what do we know? We know that angles on a straight line sum to 180 degrees. And so what we're saying then is 117 plus Z is 180. Also, we know that angle R is going to be 77 degrees because of Z angles. So when we input our Z, we're really nice. So now we can replace them now with 77 and 63. But notice that all of those angles right there, the 77 and the 63, if you add those two angles, that will give us the angle at B. And so the angle at B is 140 degrees. Cool. Now we only have one more angle inside of the triangle to find. Let's call that angle right there T. If we call that angle T, we know that angles in a triangle sum to 180. And so we can transpose for angle T. And by transposing for angle T, we get 180 minus 140 minus 12, which is 28 degrees. So now we find angle T, and angle T is 28 degrees. So now we have all three angles inside the triangle. We also know that the distance BC is 1200 kilometers. And now we need to go ahead and find the length AC. That's what the question had asked for. So now as we're going to find the length of AC, we need to look at it. Notice that the angle 28 degrees is across or opposite from 1200. And we know that the side that we want to find AC is across or opposite from 140 degrees. So we can use sine rule. So the sine of 28 degrees over 1200 is equal to the sine of 140 degrees over AC. We can cross multiply to get AC times the sine of 28 degrees is equal to 1200 times the sine of 140. And so we can divide both sides by the sine of 28. And then you input all of that into your calculator and you get 1643 kilometers. So we can put it on the diagram that the distance AC is 1643 kilometers. So that is how we would attempt that question right there. It's really easy. Nice. Notice how many stuff we had to do? Alright, notice we utilized the three facts about bearing. So this question, we have to remember that this type, it was partially filled because they left off the 117 degrees bearings from this question. All right, that is important to note. Now let's look at another example right here. It says 3 points P, Q, and R represents the position of 3 cell phone masts. Mast Q is on a bearing of 100 degrees from mast P and is 40 kilometers away. The bearing of mast R from mast Q is 150 degrees and mast P and R are 66 kilometers apart. Use the space right here to draw a suitable diagram to represent the journey. Alright, and then use your diagram to establish the size of angle PQR and hence find the bearing of mass P from mass R. Okay, so this is quite a lot to do. So first we need to construct our own diagram. So this is type 1 where you have to construct everything. Now the point P is right there and they give us the north line. So the first thing we need to do is, the first information they said is that mass Q is on a 100 degrees bearing. Now 90 degrees bearing would be directly to the east. So we shift the point down a little bit. So it's not directly across from P, but a little bit below P. That makes a 100-degree bearing. Alright, and we can input that they're also 40 kilometers away. So that gives us the distance PQ, and it also gives us the bearing of Q from P. The next information that is given is that the bearing of mass R is 150 degrees. So we know that again R is going to be below Q, but not directly below. It's just on a bearing of 150 degrees. So we input that. And then they told us that the distance PR is 66 kilometers. So let's put that right there. And that is your diagram. Just that simple. Easy. And that is part A covered. Now that we've construed our diagram, alright, now we need to go ahead and work out the size of angle PQR. Now, so let's call angle PQR X. And also, there's another angle at the point Q, right? So that angle right there, let's call that angle Y. Now what do we know about Y? We know that co-interior angles sum to 180, and so 100 plus Y would be 180. And when we transpose it, that would give us that Y is 80 degrees. Cool. So we can change that to 80 degrees. Now what else do we know? We also know that at the point Q, we know that angles at a point sum to 360 when you make one complete revolution. And so we would know that 80 plus 150 plus angle X is equal to 360. And so by transposing it, that gives us that X is 130 degrees. So finally, we can tell them that angle PQR is equal to 130 degrees. So we put that on the diagram right there. Cool. Now the next part of the question said, hence, find the bearing of mass P from mass R. So we need to find the bearing of mass P from mass R. So let's put on our north line at point R. Alright, and we need to find that bearing right there. We see it spin around. We need to find all that angle. Now, if we need to find all that angle, right, what we can do is say that all of that angle would be 360 minus the inner angles that we need to find. The inner angles, we can just call the angle inside the triangle W, and we call the other angle right there Z degrees. Now look at that. Now co-interior angles again sum to 180. So we know that the 150 plus Z is going to be 180, and so Z works out to be 30 degrees. And then we know that angles at a point sum to 360. And so that would mean that the bearing plus W plus Z equal 360, because angles at a point sum to 360. Beautiful. So now, what do we know? What we do know is we can use sine rule to find the angle W, because that's the only way we can find the angle W. We need the angle W so we can find the bearing. So if we use sine rule, look at it. We would then know that the sine of 130 degrees divided by 66 is equal to the sine of W over 40. So we can transpose and get 40 times the sine of 130 is equal to 66 times the sine of W. So we make sine W the subject. So when we transpose, we get sine W is equal to 40 times the sine of 130 divided by 66, which is 0.464. We then take sine inverse of 0.464 to get 27.7 degrees. So since we get that W is 27.7 degrees, we know that the bearing of P from R is going to be 360 minus 30 minus 27.7 degrees, which is 302.3 degrees. Why is that so? Because we said that angles at the point R, it's sum to 360 degrees. So now we see that the bearing of P from R is 302.3 degrees. And so we just put in all the answers on the diagram there. And also the angle PQR is 130 degrees. and we also have their diagram. So that is how you do this question right here. And remember that this question, you had to construct your own diagram. Alright, so let's look at one more question right here. So this question says the Brian Lara Cricket Academy is 70 kilometers due east from the Queen's Park Oval. The bearing of the Darren Ganga Recreational Ground from Queen's Park Oval is 15 degrees and from Brian Lara Cricket Academy is 290 degrees. So on this copy right here, we need to fill out the angles in the triangle, and then we need to calculate the distance between the Darren Ganga Recreational Ground and the Brian Lara Cricket Academy to the nearest kilometer. So this question right here, they give us the representation. Only thing we need to do is fill out the angles. Okay, so first thing we need to do is put in our north lines. Alright, so the first thing we need to do is input our north lines and then look at it. Right? So we input our north lines from Queen's Park and Brian Lara Cricket Academy. And then it said the bearing from the Darren Ganga Recreational Ground from the Queen's Park Oval is 15 degrees. Remember, bearings is measured from position. So from Queen's Park Oval, the angle from Queen's Park Oval to Darren Ganga, that's 15 degrees. So we'll put that there. They then told us that the Brian Lara Cricket Academy is 70 kilometers due east from Queen's Park Oval. So we put the 70 kilometers as the distance between Queen's Park and Brian Lara Cricket Academy. And then the next thing they told us is from the Brian Lara Cricket Academy, the bearing is 290 degrees. So we put that right there, 290 degrees. That's our bearing. That's the bearing of the Darren Ganga Recreational Ground from the Brian Lara Cricket Academy. Now once we have all of our bearings, we're pretty cool now. Alright? So now we need to find the angles inside of the triangle. So to find the angles inside of the triangle, let's call the angles at Queen's Park X. Let's call the angle at Darren Ganga Y. And let's call the angle at the Brian Lara Cricket Academy Z. Now once we call those angles X, Y, and Z, right, we know that angle X. What happens at angle X? Well, first thing, since we have the north line there, we know that between the north line and the Queen's Park Oval, that's 90 degrees. Right? Why is that 90 degrees? Because look at that. Those are two perpendicular lines. The Queen's Park Oval to Brian Lara Cricket Academy and the north line, that's 90 degrees. And so what that means is that 15 degrees plus X is 90. And so X is 90 minus 15, which is 75 degrees. Because they told us that Queen's Park was pretty much to the west of the Brian Lara Cricket Academy. Alright? The next thing is that we can find the angle Z. How can we find the angle Z? Now look at it. If you spin around, coming up to Z right here, coming up around to Z, you spin and stop right there, just the angle on the inside. Right? So we know 270 plus the angle Z would be 290. And so the angle Z will be 20 degrees. Now that we find angle Z and angle X, we can put those inside of the diagram, and so now we just need to find angle Y. But angles in a triangle sum to 180. And so angle Y is going to be 180 minus 75 minus 20, which is 85 degrees. Now we can go ahead and use sine rule. Now using sine rule, what do we know? We know that the sine of the 85 degrees over 70 will be equal to the sine of 75 over W. We're just calling the length that we need to find W, which is the distance from the Darren Ganga Recreational Ground to the Brian Lara Cricket Academy. So then we can transpose it to say that W times sine 85 is equal to 70 times sine 75. And so W is going to be equal to 70 times sine 75 over the sine of 85. We put that into our calculator and we get 67.9 kilometers. Now, it said round off your answer to the nearest kilometer. And so we're going to leave our answer as 68 kilometers. Alright? So in reviewing, we need to remember there are three types of bearing questions. Right? The one where information is given to you, where you have to construct the diagram, as we did in question 2, we had to construct it completely. There's going to be information given to you with a partially filled diagram, as we just saw in question number 3. And there's also when they give you all the information with everything on the diagram, and you just have to go ahead and do some calculations. We didn't do any of those examples because we wanted us to look at both the partially filled and also when you have to construct your own diagram. Alright, so that's it. That's it on bearings. I really hope this video was helpful. So stay tuned and see you next time. Have a blessed day.